Okay, can you see it?
Yeah, I'm seeing it.
Okay. You are given an array of k linked lists.
Yeah,
Each linked list is sorted in ascending order, okay? Merge all linked list into one sorted link and return it. Uh,
yeah,
okay, this seems far too easy. Let's see
yeah, 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 yeah. Depend on your approach.
what is the trick here. Ah, what is the trick here? Um,
So, what solution came to your mind? Could you share it with me?
I'm just checking the constraints first. Uh,
Okay.
K, what is K? K is the amount of
K is
lists.
number of array. Yeah,
Okay, so it could be thousands of lists, and the length is um,
yeah.
wow. Um, okay, this is a sorting algorithm, and the sorting only works well with two lists at a time. So my idea would be one, put all the values in a list and then sort them all.
Okay.
Put all nodes in a list and sort them. To sort them in pairs of lists, merge, sort. Now, I imagine that if this is a coding interview, that's what they
Yeah.
want to see, because otherwise is
Sorry, I don't understand the point number two. What do you want to achieve in the point two?
because they can be thousands of lists. You group them in
Yeah,
pairs, merge them, and keep merging lists.
yeah.
And that's what would happen. So
But what do you mean by sort them in pair of list? What does pair
uh,
do?
merge them in group.
But you already merged all the nodes.
So okay, let's do this exercise twice. So
Okay, okay, I got it. So, what is the time complexity do you think this approach?
in both, it's O the n log n for both options,
Okay,
both
okay,
space
okay.
and uh, in time, and O the n in space.
Okay, but the question is given n and k. Could you describe it with the term in terms of n and k? Like k is the number of subarray and n is the elements in the subarray.
Repeat.
So the question described they mentioned K, and also there is N. So could you write the time complexity in terms of N and K? Like K means the number of sub-array in the list. K means number of sub-array in the list, and N is the
K
number of elements
is
in each
number
sub-array.
of lists, and N is
Uh,
the,
uh, K means number of sub-array. Yeah, same thing. Array.
okay.
Given an array of K, okay, the number linked list, and you could consider N as the length of the each array,
A
length of
single
each array.
something like this.
So yeah. So you could assume all the sub-array has the same length of N, and so you have N and K. Now describe the time complexity with N and K.
Yeah, it would be in this case M would be all the elements.
Okay, I got it. So the time complexity would be O and K log N K. Okay, I got it.
So the
Okay.
the first option would be let's say all nodes. It would be an empty, and for L L in list, for element in L, all nodes append element. Merge or linked list and return. And sorted nodes, it will be sorted all nodes. And now, well,
But
for
you are given linked list, not array.
that is
You cannot
correct.
access.
That is correct. This is not going to work like this.
Yeah. Also, line number 16. Also, yeah.
Well, it could be that someone implemented. So
Yeah.
while no, this will be um,
Take the head from the L.
node is L, while
Yeah.
node
Dot next.
all
Yeah.
nodes append node value, and node is equal node next. Something like this.
Okay.
Now all the nodes are sorted, and now we have to convert into the uh, linked list. So for each element in nodes, previ for each
Just create a new node, something like that.
it will be um, the value element,
Yeah. Right.
and it will be the next if okay, if previous node, if there is a node, then the previous node next equal node, and this start to look a bit ugly. Previous node equal node. Return. And now I think I lost the head.
Yeah.
Let's see if this compiles.
Sure. You're not logged in.
I'm not sure what is happening. Is because I didn't sign in?
Yeah.
I see, I see, I see.
Okay, indentation problem. You just keep it aligned with the function.
The indentation, yeah. Okay, so
Okay, it all
the,
seems fine. Okay,
the,
you can submit.
this is working, but I'm almost sure this is not
Okay, you can take a look.
what the examiners want. So okay, bets 90%.
Yeah, but
This one,
memory only 20%.
the memory. I have to reach the conclusion that the people who lead code did something not very good.
Okay, so what do you think you could make better of this?
Yeah, well, there are things missing. For example, the docu strings,
What?
uh, sort linked list, sort a collection of sorted linked lists. This is a docu string, and this is something important
No,
to
they
have.
don't want you to sort. They just want you to merge. You are, yeah,
No,
you are absolutely right, but you're sorting it, but they want you to merge it.
when you do the job interview, it probably is more important to discuss the code than to complete it. Um, so this would be again the complexity. The complexity seems to be here correct. Um, Option one. But I don't think this is what they wanted.
What you are thinking? Which approach?
By the way, so I think what they want is something like def merge two lists.
Yeah,
List
yeah, good. Okay,
A, and this is a list node. Oops. And list B, and this is also an optional list node. And I'm going to do it again because I don't think the interviewer uh, would be satisfied otherwise. What we are doing here is if there is a list A, value A equal list A dot value. Oops, val. If list B value now if there is not a list A, we return list B, and if there is no list B, we return list A. However, if there is list A and list B, then node is equal list node, where we pass the value. If value A is less than value B, then we are going to take value A. So value A, and we need the other list, which would be the tail would be value, oops, forgive me, list A, and this will be next list B. And if not, it will be the other way around. Now,
okay, you are doing in recursion. Okay.
yeah, this is a lot more complex than just putting everything
No, I got it. You just keep continue.
into a vector and ask the computer to sort it, because we are writing the sorting algorithm itself. Can we hide? Yeah. So for new if length of list is equal to 1, we return lists of position 0, because this one is also a recursive.
Yeah, got it.
Otherwise, I'm not sure how do we pair, how do we make pairs. For index in range length the list from 0 to length of list, making jumps of 2. New list. If index plus 1 is still in range list, how does no, if index plus 1 will be outside, then new list would append the list of index, because this is an odd number. So if there are only 3,
Okay, but you put one equal instead of double equal. On line number 33.
repeat the question.
On line number 33, you put one equal instead of two equal.
Yes, because
Equal sign, two equal sign. I think it could be
for
double equal.
three lists, index will be equal
On
to
line number 33.
Yes.
You put one equal sign, but I think you have to put two equal sign to compare it.
That's
Yeah,
correct.
I'm talking about that.
Okay, so if it's not, new linked list is going to be merge to list index list index plus 1. And that's how we merge. This is how we reduce two lists.
Yeah, got it. You make it up.
And after we do this, return self merging list, and we pass the lists. Oops. And I think that's it. I'm not sure if it will compile. I mean, the solution is not
Yeah,
very long,
I
but
think it's good.
we,
No,
we,
it's just okay.
we will see, because this is a lot more complex.
No, it's just fine.
Optio, yeah, but sorting algorithms are usually quite difficult. And I'm not sure if this is even as efficient. Max recursion.
more better than the sorting.
Um, well, the first thing that I am going to do is to put this outside the class. And test if it works. So list the 0, list of 1, here I'm not even sure if there is a print for the list.
In some test cases, you have only one list, so there is no one list one. You should remove some test case from there.
I should
Yeah,
remove.
remove some case, either case 2 or case 3 because those have only one or two elements. Test case 2 or 3.
Sorry, repeat.
Uh, you should check test case 2 and 3. Remove them from the test case because they only have one or zero length of the list. Go to the test case section. Check case number 2 and case number 3.
Yes.
Yeah,
But but
yeah,
uh, but but, uh,
this
but at least case
the
1 should
issue. You
work.
can remove them simply. No, because you want to access list of one, but there is no list of one for the test case 2. Your output in
So
blank.
this is 1
I think there is
4
some issue with the
5.
return.
1 4 uh, print list 0. It doesn't seem to work. So these are identical, so this piece of code is not working. I'm not sure why. Um, so let's check again. This is 1 1 4 3. So
Your code is not merging, just returning the first element from the list.
repeat is not.
So your merge to list function is not working. It is just simply returning the first element of the list.
Okay, in this case the A should be 1 4 5 and B should be 1 3 4. So
Yeah.
there is a list.
Yes, yes.
If there is a list, then the value A is
Yes.
1, and if there is a list B, the value B is also 1.
But
So
you are returning instantly. If there is a list in B, you are returning list A on line number 15. So your code is breaking there.
I think I can see the problem.
Okay.
Yeah, now is working.
So
This is now is 1 1 3 4.
but it should be 145,134. No, no, yeah, yeah, it should be 1 1 2 3.
Uh,
Okay, you are marking only two elements, so it would be 1 1 and a 3
one
4 4
one
5.
three
So
four four five. Yes.
4 4. Yeah, it is fine, very much fine.
So
So you can comment out what those things.
and now seems to be working.
Yeah,
Now
okay,
here I
you can
guess
submit.
if length list equals 0, that's the case. Return none.
Yeah.
I think is the thing missing. Um, so okay, now
Okay.
it's working
So
126 milliseconds, and as you can
what is
see,
the time complexity?
it's a lot slower. The time complexity again is complexity time space where m is the amount of values.
What is the time complexity?
The time is m logarithm of m.
Oh, I don't think so.
Why?
Yeah, think about it. Your time complexity is less than that.
No, because it's recursive.
Sorry?
So it's m logarithm of m. This
Yeah, but that's for
this
sorting
algorithm,
algorithm. But
yeah, this algorithm is called merge sort.
yeah, but the complexity is wrong. I would suggest you to redefine it. Take a look again on that.
So what do you think is the complexity?
Could you think could you look on that again and think
Could I look into?
could you think about the time complexity again if you could figure it out?
Oh yes, the time complexity. It will be the amount of. I mean, I guess it depends on the amount of lists. So in this case, let's say L is the amount of lists and N is the amount of each list. So this will be something like this. Uh, L by N.
But why it comes from the log?
Because we paid, we make pairs of lists. So in the
L
first,
is the amount of
this function call itself, but it call itself each time with half of the amount of list. So if there are 8 lists, the first time it's 8, the next time it's 4, the next time is 2, list, and the next time it's already sorted. It's only one.
Okay, but the length of the list is in length of the subarray is increasing.
That's correct. Yes, it's increasing.
Yeah, so you should also consider that
The hmm,
also why you are writing
so
space of m.
if there are 8 lists with 8 elements, the next time it will be 4 lists with 16
16
elements.
elements.
You with sorry. Um, so yes, this will have a cost per list of 4 pairs multiplied by 8 elements. It will be 16. This will be two pairs multiplied by 16, 32. Hmm. And this will be the cost of 32. And if we have more, here will be 8 pairs. Yeah, I'm not sure if I know how to calculate the cost.
Okay, so okay, so we need to describe it with the terms of n and k. So n is the number of subarray, right? Sorry, k is the number of subarray, right? Subarray in the list.
K, sorry,
K is the number of subarray in the list, right? Yeah, instead of n, write k there because the question is mentioned k. Instead
sorry.
of l, write k there on line number 11.
Yeah, instead of L,
I think it should be mentioned as k because it is described in the question as k, right?
when we are talking about the big O, is usually referred to the worst case.
Okay, what is L mentioning? What? What is L?
The L is the amount of lists.
But you need to mention the K. You need to describe it in terms of K.
In terms of K,
K and N. In terms of N and K. That's what the question is
is an N
showing.
is the length of each list.
Yeah, but you need to introduce K there because the question is mentioning K.
The question is mentioning K. Ah, okay. You mean that
Yeah,
this should be called K?
yeah. That's what I'm saying.
Sure.
Okay, so uh, you are saying that the time complexity of
I think that's it. Do you want to try now?
what? Okay, go up, go up. So the time complexity is O of k n into log k, right?
Yeah.
Okay. So could you explain why it comes this into this term?
I put log of K because in each step we reduce the amount
Yeah, I got it.
of lists by two.
Yeah, yeah, yeah. And what about K star n? K dot n.
What about k?
What about K dot n? You put K star n before the log K, right? How this comes?
Being n the amount of elements that has the list.
Okay, so
I-
in every iteration of log K,
in the
you are handling K.
in the worst case, the n will be equal to 1, and we will have to sort the whole list. If it's partially sorted, then in the best case there is only two lists, so we just the cost will be n.
Okay, okay, you did great job. Yeah, I'm happy with that. So yeah, you have done a great job.
Okay, now is your turn.